Here mg will act here. Then let me apply force F. I'll calculate the particular minimum value of force F which is needed to topple the block. Then when you apply that particular minimum force, it is kept on rough surface, so the friction will be acting here. Here also the friction acting, and we applied a force. Here also friction will be acting. Then about point P, it is going to topple. Here P2, you call P1. About this point, we'll discuss the torque. The torque due to applied force will be like this. Torque due to mg will be in this direction. Unless I can show like this is the torque due to the applied force F1. So what is the height H1? This will be H1 and this is F1. So the torque here will be clockwise. No? Then torque due to this will be, and let me write it here. Torque due to applied force about point P1 should be 0. So F1 into H1 clockwise. Mg into B1 Y2 anti-clockwise. Here this one. H1 into F1 clockwise. Mg into B1, this Mg will be anti-clockwise about this point. Then we'll solve for minus this is the force required. So definitely you can see here which is greater, H1 is greater than B1. What's that like? Yes, okay. B1 greater than H1. Now in this case, torque due to the second diagram. I'm asking you to look at here, second diagram. Now the torque due to applied force about point P2 will be clockwise. Torque due to the weight will be anti-clockwise. Okay, fine. Then the normal reaction will be acting here. Here also the normal reaction will be acting here. So when you apply that minimum force, which is required to topple, the normal reaction will be acting at this edge, at this corner. We are going for this minimum force. We'll write down the equation. Torque due to all the forces acting about point P2 should be 0. What are the forces acting? The normal reaction. N2. Here this N1. So the net torque should be due to applied force F2 into H2 clockwise. Mg into B2 by 2 anti-clockwise 0. What about the torque due to the friction? Will be 0. It will intersect axis of rotation. Torque due to the normal contact, it will also intersect axis of rotation. Torque due to mg into this distance B2. When you apply that minimum force, the normal reaction will be acting at this edge or at this particular corner. Then we'll simplify this. F2H2 plus mg B2 by 2 equal to 0. F2 equal to mg B2 by 2H2. Now here H2 less than B2. So what do we expect here now? F2, you compare these two. You compare these two. Then F2 what happened will be less than F1. Means will be easy to topple. So like what actually happens when you apply force, I'll show it a little bit. So when you apply that force, it will topple like this. It will fall off. It will tip about point P. It will tip like this. When you pull this, when you pull with the force at this particular point, it will topple, it's about to topple above this point. So which case the block will easily topple here, this one. In this case, the block will topple very easily than this one. So here we have to apply the larger force. You can see B1. Here in this case, you have to apply the smaller force. So this will easily topple compared to the this block 2 will write it. Which block will topple easily? The block 2, provided if you apply a force which is equal to greater than or equal to this one. If you apply force which is greater than or equal to this, the block 2 will topple. If you apply force which is greater than or equal to this, the block 1 will topple. But altogether, the force needed to topple the block 1 is more than that of the block 2. The reason you can check it from the geometry here. Like this, we are analyzing the basics of the toppling here.